Good day, students. My name is Mr. John, a teacher at Lake Angels International School. I'm delighted to be with you again. And today I'm going to be taking the JSS2 class on mathematics. In our previous lesson, we talked about graphs in real-life situations. Today we're going to go a step further and look at travel graphs. There are various types of travel graphs, but today we are particularly going to pay attention to distance-time graph. Distance-time graphs. A distance-time graph represents the movement of an object or person in terms of distance covered and the time taken. I'll take that again. A distance-time graph represents the movement of an object or person in terms of distance covered and the time taken. Before we continue, I want us to take note of these 3 points. They are very important points when you're talking about travel graphs. And the 3 points are that 1, in travel graphs, time always appears on the horizontal axis. In travel graphs, time always appears on the horizontal axis. And 2 is that the speed is the rate of change of distance over time. Speed is the rate of change of distance over time. We can see that from the speed formula, where we learned that speed is equal to distance over time. And the last point I want you to take note of is that answers obtained from graphs, from travel graphs, are not usually exact. Answers obtained from travel graphs are not usually exact. However, to improve accuracy, larger scales should be used. To increase accuracy, to improve on them, larger scales should be used. But we can only use as large as possible a scale when we have space on our Cartesian plane. I want us to take this example and then see how we can have our distance time graph. Our example says Peter and Paul leave home at the same time for school, that is 3 kilometers away. Peter and Paul leave home at the same time for school, that is 3 kilometers away. Their journeys are shown in the graph below. Now we're going to use our graph to answer these questions. Number 1, or the first part of the question is, how long did Peter take to get to school? And the second part is, how long did Paul take to get to school? I want us to look at the graph. We have the graph of Peter and Paul's journey to school. It is a travel graph, and from what we noted, the time is always on the horizontal axis. This is the axis for time. For all travel graphs, time is always on the horizontal axis. Then, depending on what kind of travel graph it is, you would see what is on the vertical axis. This is a distance time graph, so we have distance on the vertical axis. We also have travel graphs like the speed time graph and the displacement time graphs. Those are also travel graphs. But for today, we're particularly paying attention to the distance time graph. It is called distance time graph because the distance is on the vertical axis and the time is on the horizontal axis. Now, Peter and Paul took a journey to school. School is 3 kilometers away. Finally, the last point to note is that answers obtained from graphs are not usually exact. Answers obtained from graphs are not usually exact. However, to improve accuracy, larger scales should be used. To improve accuracy, larger scales should be used. we're going to take an example to see how this applies and then know where we can make adjustments. Now, our example says Peter and Paul leave home at the same time for school, that is 4 kilometers away. Their journeys are shown in the graph below. Peter and Paul leave home at the same time for school that is 4 kilometers away. Their journeys are shown in the graph below. We're going to use our graphs to answer these two questions. The first one is, how long did Peter take to get to school? And the second one is, how long did Paul take to get to school? Now, our graph is on our graph space, and you can see that our time is always, like from what we noted earlier, is always on the horizontal axis. Time is always on the horizontal axis. And depending on the kind of travel graph, we'll know what to put on the vertical axis. Because we're treating a distance time graph, the distance is on the vertical axis. We also have other types of travel graphs like the speed time graph and the displacement time graph. In those graphs, we are particularly going to pay attention to what we place on the vertical axis. But every travel graph has time on the horizontal axis. Now, you can see that I have a red line and a green line. I indicated here that the red line signifies Peter's journey and the green line indicates Paul's journey. Now, the first question says, how long did Peter take to get to school? We can see that the distance from home to school is 4 kilometers. Their journeys ended at exactly 4 kilometers. Now, because time is on the horizontal axis, all we have to do is trace for Peter where Peter ended his journey and trace down. And this is halfway between 20 and 30 minutes. Remember, time is in minutes. Between 20 and 30 minutes. It means that it took Peter 25 minutes to journey to school. While for Paul, this is the straight line graph for Paul, and it stops at this point, halfway between 30 and 40 minutes. It means that it took Paul 35 minutes to get to school. Questions are, how long did it take Peter to get to school? How long did it take Peter to get to school? From what we have found out in our graph, it took Peter 25 minutes. It took Peter 25 minutes to get to school, and it took Paul 35 minutes. Okay, now I want us to look at something else that will help us calculate the speed, average speed it might have taken them to get to school, and that will be gradient. Now, I want us to look at something that will help us calculate average speed, and that is gradient. Now, what is gradient? The gradient of a straight line graph is the change in the values on the vertical axis divided by the change in corresponding values on the horizontal axis. In a distance time graph, the gradient of a line gives a measure of the speed at that point of the graph. In a distance time graph, the gradient of the line always gives the measure of the speed at that point on the graph. Okay, with that, I want us to solve an example to see how we can apply gradient. And the question is, the graph below is the travel graph of a cyclist who stopped once on his journey of 15 kilometers. The graph below is the travel graph of a cyclist who stopped once on his journey of 15 kilometers. We're going to be using our graph to answer these questions. The first question is, how long did the cyclist stop? For how long did the cyclist stop? The second question is, how far had the cyclist gone after 45 minutes? The next question is, what was the average speed? Now we're talking about average speed. We're going to apply the gradient. What was the average speed before the stop, and what was the average speed after the stop? We're going to leave our answers in meters per minute, but let's get to the graph to know what to do. Now, you can see, like I said earlier, that all travel graphs have the time on the horizontal axis, and this is a distance time graph. That's why it has the distance on the vertical axis, distance time graph. Now, this is the graph of the cyclist, and we're told that his journey was 15 kilometers. Distance is in kilometers, so 15 kilometers, this is where the journey stops. Okay, now the question is, how long did the cyclist stop? Okay, I want us to answer this question first. How long do you think this journey had taken the cyclist? I want you to think about it, and then your answer might be as good as mine, but whatever your answer is, let's check and see if you're correct. Now, this is the axis for distance, and this is the axis for time. The journey ended at this point. Tracing it down, this is 70 minutes. So it means it took the cyclist 70 minutes to cover his journey of 15 kilometers. Now to that question, how long did the cyclist stop? If you look at the graph, you would see that he started from rest, 0 time and 0 distance, and he continued on a uniform motion, uniform speed, until the point where he stopped. And at that point, he remained at the same distance for some time. From this point to this point, there was no increase in distance. But from this to this, as time was increasing horizontally, distance was also increasing vertically to this point. It stopped here, and time was increasing, but it wasn't increasing in distance. Now, it stopped between this point and this point. I'm going to name the first point, point B. This is point B, assuming he started his journey at point A. This is point B, and this is point C, this point. Now, between point B and point C, he had spent some time. How much time did he spend? From 30 minutes, he was there at point B, and he did not leave point B until it was 50 minutes. Now, the difference between this will tell us how long he spent or how long he stopped. Now, the highest time there is 50. 50 minus 30 is 20, and the answer to that question is he spent 20 minutes. I'm just going to write that here. 50 minutes minus 30 minutes, and that gives us 20 minutes. Let's rearrange this. 50 minus 30 gives us 20 minutes. Now, the next question is, how far are the cyclists gone after 45 minutes? How far are the cyclists gone after 45 minutes? Now, looking at our graphs, this is 0 minutes, and it decreases along to the right. 10 minutes, 20, 30, 40. 45 minutes will be somewhere in between 40 and 50, halfway through. Now, say for instance, this is 45 minutes. The question is, how far had he gone? We're looking for distance. So we're going to trace it up to the point where it touches the graph, and then we're going to trace it back to the distance. We notice that he had stopped from his journey at 45 minutes. Tracing it back to the distance axis, we have halfway between 5 and 10 kilometers. Halfway between 5 and 10 kilometers. Now, halfway between 5 and 10 kilometers is going to mean 7.5 kilometers. Halfway between 5 and 10 kilometers is 7.5 kilometers. My reason is from 0 to 5 kilometers, there are 2 boxes. It means 5 divided by 2 is going to give us 2.5. This is 2.5. So each box represents 2.5 kilometers. So 2.5 added to 5 kilometers is 7.5 kilometers. So the question, how far had the cyclist gone after 45 minutes? The answer is that he had gone 7.5 kilometers. He had gone 7.5 kilometers. You can decide to leave that in meters. And if to keep that in meters, all you have to do is multiply by the conversion factor between kilometers, from kilometers to meters, and that's 1,000 meters, and it will give us 7,500 meters. Now the next question, what was the average speed before the stop? What was the average speed before the stop? That is where we're going to apply our ability or our knowledge on gradients. What was the average speed before the stop? Now, we said that the gradient of a straight line changes in the value is the change in the values of the vertical axis divided by change of corresponding values on the horizontal axis. Now, to do that easily, I want to draw a right-angled triangle so that we can see our change in values. So, before the stop is when he started to point B. From point A to point B is before the stop. So I'm going to trace a right-angled triangle from point B. I'm tracing vertically downwards. That's it, and then to the right, and it gives me something coinciding with the origin. Now that coincides with the origin. Okay, now I want to move over there. This point point B is 30,7.5. And point A is 0, 0. I'm going to name this point X, and point X is 30, 0. Now, with those 3 points, I'm going to find the gradient. Please stay with me. Let's get to the gradient. Now we've answered the A part and the B part, so I'm just going to go straight to the C part. How far had what was the average speed before the stop? We know that average speed is distance over time. And that gives us our gradient. We stated earlier in the points to note that our gradient gives us the average speed. Now, gradient is the change in vertical change in values in on the vertical axis divided by corresponding change in values on the horizontal axis. Now, remember we said that gradient is the change in values on the vertical axis divided by change in corresponding values on the horizontal axis. Now, writing this point here, I want us to look at the values on the vertical axis. Remember that in a graph, we have x and y coordinates, and the y always represents vertical axis. Now, 7.5 is the highest point on our vertical axis. I'm just going to compute that here. 7.5 kilometers minus, and the lowest value there is 0. That is between point A and point B. Lowest value is 0. Now for the horizontal axis, we have that the highest point, which is farther to the right from the origin, is point B, which is 30 minutes minus, and then that's point A, and point A has 0,0, meaning our horizontal value for that is 0. So we have that 7.5 minus 0, we know that that gives us 7.5, and 30 minus 0 is 30. Remember, we were told to leave our answers in meters per minute. Meters per minute. But this is in kilometers. So to bring it back to meters, we have to multiply by 1,000. So 7.5 times 1,000 will give us 7,500 over 30. I'm going to bring that here so that you don't get confused. 7,500 meters over 30 minutes. All we have to do is cross out zeros, and 3 into 75 we have 25, and 3 into 0 is 0. So that the average speed between point A and point B, that is before the stop, is 250 meters per minute. That is our average speed before the stop. Now, average speed after the stop. Average speed after the stop. We'll go to our graphs so we can trace the points down and then check the horizontal values and vertical values. Now, the point after the stop starts from C. And I'm going to name the extreme, the point of final stop, D. Now, looking at that, let's trace our right-angled triangle. Our right-angled triangle, I'm starting from point D. It comes all the way down to the first stop, which is this point. And then I'm tracing it back to C. Now, the point D, according to our coordinate system, is 70, 15. And this I'm going to name Y, this point, naming Y, and that is 70, 7.5. And point C is 50, 7.5. Now, with those 3 points, we're going to go and solve the average speed after the stop. The average speed after the stop. Now, let's get right there. Now for D, what was the average speed after the stop? I'm just going to transfer our coordinates for D, which is 70, 15. For C, sorry, Y first. For Y is 70, 7.5. And finally, for C, we have 50, sorry, 7.5. Now, average speed. Remember, our average speed by now, we should have memorized it. That is the same thing as our gradient. Formula for average speed, I'm just going to put it there. Distance over time. Change in distance over change in time. Now, gradient will be change in values on the vertical axis divided by corresponding change in values of the horizontal axis. Remember, horizontal axis is always time, and the vertical axis, in this case, is distance. So, for the horizontal, for the distance, I'm going to pick this. Now, our distance, the highest point is 15. This is value for y, and this also. Values for y is 15 kilometers minus 7.5 kilometers all over. Now for the x-axis, we know that y is 70,7.5, which is this. Now for x, 70 minus, and that's C. C is the next horizontal point, which is minus 50. So what have we done so far? We did 50 minus 7.5, and now 70 minus 50. Now 15 minus 7.5, we know that is going to give us 7.5 over 70 minus 50 is 20. Remember, we are told to leave our answers in meters per minute. So I'm converting 7.5 kilometers to meters, and that will make me multiply the numerator by 1,000 meters. And that gives me 7,500 meters over 20 minutes. 7,500 meters over 20 minutes. All we have to do is strike out the zeros, and then 2 into 7 is 3, remainder 1. 2 into 15 is 7, remainder 1, and 2 into 10 is 5. So that our average speed after the stop is 375 meters per minute. 375 meters per minute. Now, if you look at the answer for question C and the answer for question D, you notice that there was a tremendous increase. Average speed before the stop is 250 meters per minute. Average speed after the stop is 375 meters per minute. And this is because of the gradient, because of the degree of inclination. The degree of inclination of the graph. Degree of inclination of the graph. Now from this, you'll see that there is a gradual slope, while from this point it is steep slope. Now with that knowledge, I will be giving you, sending an assignment, and I want you to attempt it. And please make sure you see this video in its detail so that you can be able to answer the questions. Thank you very much for your time, and please do remain safe.